Hello. Today we're going to be looking at problems from 5.2 where we are testing a claim about the population mean, testing a claim. So we do have some things that we learned in 5.1 that we'll kind of reference back to that will be helpful for us in 5.2. And we have two different methods as far as how we complete a test, complete a hypothesis test. We can use the p-value method and we can use the critical value method. So I'll be showing you both methods as we progress through these problems. So let me start with sharing my screen. Okay, so this first problem we're looking at is number 2. And I wouldn't call this a word problem per se because they literally just give us the claim and give us our info and our sample statistics that we need to complete the test. But our claim is that the mean mu equals 50. That mean is 50. Our significance level, our test level is alpha equals 0.04. Our standard deviation, and particularly it's called the population standard deviation, is 3.92. And our sample statistics, x bar equals 49.6 and n equals 69. Okay, so the first thing we're going to do for every test is set up the hypotheses. Remember from 5.1 that you have two hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis is the one that must contain equality. Okay, so your claim will either be the null hypothesis or the alternative, and how you'll denote which one the claim represents, which hypothesis the claim will be, is by looking at the symbol that's used, the mathematical symbol that's used in the claim. If it contains equality, whether it be equal to, or whether it be less than or equal to, or greater than or equal to, all three of those contain equality. If your claim contains equality, any one of the symbols, equal, less than or equal, or greater than or equal, then it must be the null hypothesis, okay? If it contains a symbol of inequality, such as not equal to, greater than, or less than, all three of those are symbols of inequality, then your claim would have to be the alternative. In our case, we have mu equals 50, so our claim must be the null hypothesis. It must be HO. Mean mu equals 50. And I'm going to go ahead and put right here. Okay. So how we write the other hypothesis is we take it by considering what the opposite of equal will be. Okay. So the opposite of equal would be not equal. Okay. Just like the opposite of less than or equal to would be greater than. And the opposite of greater than or equal to would be less than. So you remember from 5.1, you have particular pairings. These symbols go together. Equal is with not equal. So if HO has equal, HA must have not equal. Less than or equal to is with greater than. So if HO has less than or equal to, HA must have the greater than symbol, the opposite. Opposite of less than is greater than. And then if HO has greater than or equal to, then the alternate must have less than, okay? So keep in mind, that's how you set up your hypotheses. Every time we do that first, okay? We either see the claim written out plainly for us like this one, or we take the word problem and we determine the claim, write the claim, okay, in a mathematical symbol such as this. In this case, it was just given to us. All right, so choosing the correct letter, you want to just find the one that has the hypothesis set up correctly. Mu equals 50 is HO. Mu does not equal 50 is HA. So that would be B. Okay. All right. Now we're asked to calculate the standardized test statistic. And I am going to get to that, but even though it doesn't ask me, you need to also determine what kind of test it is that you have, because that's going to have an effect on how you find the p-value, or in this case, how you find the critical value. Okay, so we do need to determine the type of test we have. Even though they don't necessarily have a question asking that, it has to be determined. Okay, So the way that you determine what kind of test you have is you look at the alternative hypothesis, okay? If we have the not equal symbol, then this is a two-tailed test, okay? Also, when you are testing, your decision is always based on the null or around the null. Your decision to either reject or fail to reject is about the null hypothesis. Now, that doesn't mean that the null has to be the claim necessarily, but you always test the null hypothesis. In this case, we're testing the null, and the null happens to be our claim. So we'll either say we reject the null, which means we reject the claim, or we say we failed to reject the null, which in this case would mean we failed to reject the claim because the claim is the null. Okay, it won't always be, but it happens to be so here. Okay, so because this is a two-tailed test, I'm going to go ahead and draw me a picture. Remember, a picture says a whole lot. A picture's worth 1,000 words. I'm going to draw a picture, and I'm going to go ahead and illustrate that it's a two-tailed test on my picture. So the areas in my left and right tail are my shaded regions. And in this case, they represent my critical value regions because this is a critical value method problem. If this was a p-value method, then the two areas together would represent my p-value, okay? But this is the critical value method, so the two regions together make up my critical value region. What that means is, if this is my critical value, my critical area or critical region, it's a rejection region. If my test statistic ends up falling in either of those areas, then that means I reject my null hypothesis. So these critical value regions represent my rejection region. So I'm going to go ahead and put that. If this had been just a left-tailed test, then I would only have the one rejection region. But it's two-tailed, so I have two. Okay, now we're going to specify how big this area is in just a minute, but right now I'm just labeling it from this information, okay? All right, now to get the standardized test statistic, okay? Now, that is a formula. Our standardized test statistic, we're transforming X to a Z-score basically. So Z equals X bar minus mean mu all over sigma divided by the square root of n. Okay. We did go over this in 5.1, calculating the test statistic as well. I think we saw this in module 4 as well, calculating or standardizing that test statistic. Okay. So we're going to enter in, this is just a formula. Okay. So we're going to enter in our actual values into this formula to get our test statistic, our Z-score. And this will be what you'll use every time, okay, when you have to get the test statistic. Okay, that is because we're given a sample and we're given the population standard deviation. Okay, so X bar minus mu over sigma divided by square root of n. So X bar is 49.6. And what I might do is kind of arrow down here where I have a little more room. Z equals X bar minus mean mu over sigma divided by square root of n. So X bar is 49.6. The mean mu is 50. Sigma is 3.92. And that is divided by the square root of 69. Square root of n is 69. Okay. So I'm going to put in 49.6 minus 50. I'm going to do that first. Then I'm going to divide that by this whole value here. So I'm going to put that whole thing in parentheses. 3.92 divided by the square root of 69. So I'm putting that. I'm showing that this difference here on top. Uh-oh, it's in the light, in the glare. There we go. I'm showing here that this difference on top, which was negative 0.4, is going to be divided by 3.92 over square root of 69. And I put that in parentheses so that the calculator understands that this value is divided by this whole value. Okay, as you can see on my calculator. All right, and I've got a negative 0.85. If we round to two places, it does say round to two decimals. So that would be a negative 0.85. Okay? Negative 0.85. All right, now what we're going to figure out is what these boundaries are for our shaded region, for our rejection regions, so that we can determine whether or not this test statistic lies in either region. Okay? So we need to figure out what this bind is here, this left side and this right side bind is, or bound is, so that we can determine whether or not this test statistic falls in either of these regions. It won't, of course, lie in both. It'll lie either to the left or to the right, or perhaps not either. It may lie here in the middle, where this is the failed to reject region. Okay, so let's see. Now, how do we determine the bounds here that show us how big our rejection regions are? We use the critical values. Okay, how do we get the critical values? Well, this is what we do. Alpha is our level of significance, also known as our test level, or how confident we are in the accuracy of our tests. That's basically what it is, how confident you are, excuse me, that your test is giving you good results. So alpha is the test level or level of significance. It is 4% or 0.04, which means we have this alpha value. This is an area that we have to split between these two regions. So 0.04 divided by 2 is 0.02 in this area. This region here is 0.02, because it's half of 0.04, and this region is 0.02. So the area in these shaded regions is really small, only 0.02. So what we're going to determine is what are the standardized scores that correspond to that area. Okay, that's what we're going to figure out. Now, keep in mind that the areas are the same in both tails. So this should be the same z-score. One will just be negative and one will just be positive. And then we'll compare our z critical values. I'm going to put like a little subscript, z naught, so that way they stand out differently from our z test statistic, because this is a z-score as well. So the critical values that we're finding are represented by z, but we're going to use a little z sub 0 to show that those are our critical value regions. And we're going to compare our test statistic to our critical values. Okay, so let's get what the critical values are. So let's say I want to find that one first. I'm going to scoop this up. So let me put critical values, and let's get the negative z-score. So think about it. I'm given the area that corresponds to it. I want to find the z-score that corresponds to that given area, that corresponds to that 0.02. So what I'm going to do is I'm going to use inverse norm, which is what we used back in module 4, if you recall. When you're given the area or percent or probability, whatever you want to call it, when you're given the area or probability or percent, and you want to find the score, whether it be a z value and x value, you want to find the score that corresponds to it, use inverse norm. So the inverse norm, I'm going to tell the calculator what the area is to the left. And then because we're dealing with critical values, our mean and deviation will be 0, 1. So our area to the left is this 0.02, and our mean is mu is 0, our deviation is 1. Remember, we're standardized, okay? So that's why we have a mean of 0 and a deviation of 1. We're talking about a critical value z-score, okay? All right, so I'm going to use the calculator. I'm going to find inverse norm by pressing second vars. Remember your calculator where all of your distributions are located, second vars. And then number 3 is inverse norm. Okay, so my area to the left is 0.02. I have a mean of 0 and a deviation of 1. Remember, if you don't have a TI-84 color edition, you don't have this option right here to state whether it's left, center, or right. Yours will by default be left. Okay, so I'm never going to change this on mine since all of our calculators are not CE, the color edition. And because, again, when it's not color edition, you don't have this option. So I'm just going to keep it on the left tail, which is why I found the negative one. Let me scoot that down a little bit, which is why I found the negative one, because I knew the area to the left was given. I didn't have to figure it out. So the area to the left, okay, so inverse norm 0.0201. Like I said, if you don't have a color edition, you probably don't even see that word left. This is all you would see. Okay, you're going to press enter, and there is your critical value, negative 2.05, and it says 0.53 or 0.54, but that 3 won't make that 5 go up, so we're just going to leave it negative 2.05. Okay, so this negative z-score is negative 2.05. Well, look, this positive z-score has that same area, but it's in its right tail. So these z-scores are the exact same. One is just negative and one is just positive. And that is because the areas in the tails were the same. Okay, so you're going to select A. These are going to have like little circles here where you select it for being multiple choice. You're going to darken the circle here by A. And the critical values, they already put the plus or minus in for you. So you've got 2.05 is all you got to type there. When it's two-tailed, you will have 2 critical values. Okay? So they went ahead and put in the plus or minus for us. We don't have to do that. Sometimes you'll have to actually separate them by actually writing them out and separating them with a comma. But in this case, they used the plus or minus symbol, and on this empty blank, all we had to do was just type 2.05. Okay? So either way, sometimes you have to actually write them out and separate the numbers with a comma, and sometimes the plus or minus takes care of the fact that there are 2 of them, and all you have to do is type 2.05. All right. Now, here's the thing. We've got our critical values. Now let's compare our test statistic to our critical values in reference as far as where does it lie. So keep in mind, in the fail to reject region here, in the unshaded region, you're dealing with the standardized Z curve. So you have 0 here in the middle at mu. So think about where, or gauge where this negative 0.85 would lie in reference to 0 in the middle and negative 2.05 here to the left. You don't have to worry about here to the right because it's negative, so we know it's not over here. So negative 0.85 would be actually closer to 0. It would be here in this region somewhere. So it would be in the fail to reject region. And that is, again, because it's not smaller than negative 2.05. It's actually bigger. So it's over here in the fail to reject region. Okay? So negative 0.85 lies to the right of our CV, which is just short for critical value, lies to the right of our CV, negative 2.05. So it lies in the fail to reject region. It lies in the fail to reject region. Okay? Now, we are, let me put decision, fail to reject H naught. Okay, that's our decision. What we're going to do now is just interpret it here, checking multiple choice A, B, C, or D. But the decision, because again, our test statistic lied in the fail to reject region, so our decision is fail to reject H naught. Keep in mind that H naught was the claim. So we are failing to reject the claim. So because we are failing to reject the claim, because the claim was H naught, we say there is not sufficient evidence or not enough evidence to reject the claim. We failed to reject the claim, so we say there is not enough evidence to reject the claim. Okay? If you have to, go back to the interpretation, how you interpret your decisions. That was in 5.1 also. It was a little table that I created, and I displayed it on the video in 5.1. So you may want to go back to that to make sure that you understand the interpretation of this decision. Whenever your claim is H naught, your interpretation is written in terms of reject. You'll either say there is enough evidence to reject the claim, or there is not enough evidence to reject the claim. That is when H naught is the claim. When H naught is the claim. When HA is the claim, your interpretation is written in terms of support. You'll say there is enough evidence to support the claim, or there is not enough evidence to support the claim. That's when your claim is HA. But in our case, our claim is HO, so we say there is not enough evidence to reject the claim. So we failed to reject HO, and we say at the 4%, so it's either A or B because that's the only one that says fail to reject. So we can toss out C and D for sure. So we just need to determine whether it's A or B. So let's read A. A says fail to reject H naught at the 4% significance level. Remember, that's your test level. At the 4% significance level, there is not enough evidence to reject the claim. That is key. So it is A. There is not enough evidence to reject the claim. Okay? When HO is the claim, it's written in terms of reject. When HA is the claim, you see support. Okay, so that's why B couldn't be correct, because it uses the word support. But we know that HO was the claim. Okay, so it has to be A. All right. And unfortunately, when you're dealing with the critical value method, this is the process. This is what you kind of got to do. We can do the p-value method on the calculator, so I will show you that when we get to it. All right, here's another example using critical values. So we're going to have rejection regions. Excuse me. It says a company claims that the mean monthly residential electricity consumption in a certain region is more than 860. So a company claims. So right there, they're telling us in that first sentence, that's our claim, that the mean monthly consumption, mean mu, is more than will be the is greater than symbol, 860. Okay, so there's no equality here. It's just is more than, strict inequality. Okay, let's read the rest. It says you want to test this claim. You find that a random sample of 62, so N is 62. That's where we're getting that, our sample size, N. A random sample of 62 residential customers has a mean monthly consumption of 900 kilowatts. So that means from our sample, they had a mean monthly consumption of 900. So X bar, your sample mean is 900. We're going to test using our sample statistics. We're going to test whether or not this claim is accurate. All right, it says assume the population standard deviation is 126. So sigma, okay, standard deviation is sigma. Assume that the population standard deviation is 126. And it says at alpha equals 0.05, can you support the claim? Notice that they use the word support. The reason they did is because that tells us the claim is HA, okay? And right away, I knew that the claim would be HA because look, the claim does not contain equality. It's a strict inequality statement. So let me put alpha, our test level is 0.05, okay? So I'm going to set up my hypotheses. Our claim is mean mu is greater than 860. Our claim has to be HA because it is a strict inequality. It does not contain equal. So HA is our claim. Okay. Now, because we've got the alternative hypothesis written, we've got HA written, we now can find HO. Because remember, when we set up our test, we're testing HO. Even though the claim is HA, we will test whether or not to reject or fail to reject HO. And then that will tell us about our claim. So the opposite of greater than is less than, and then HO has to contain equality. And then we still got 860, okay? So HA determines what kind of test you have. This is a right tail test. This is a right tail test. Okay, so right tail, this area here in the right tail is going to be shaded. Okay. All right. Now, let's choose or identify HO and HA. We already wrote them, but let's just choose the multiplication. Make sure you choose the right one that has the right number also, because notice that they threw in 900 a few times here. Remember, 900 is X bar. We're testing the claim for the mean mu, the population mean. That's just the sample mean, okay? All right, so less than or equal to 860, greater than 860, and the claim is HA, so that answer would have to be D. Okay. Now we're going to find the critical value, and depending upon what kind of test you have, you may have just one critical value. You may have two. Now we have a right tail test, so we have one critical value. Okay, we have just one. So the area in this right tail represents alpha, or is represented by alpha. Okay, we're looking for the z-score critical value that corresponds to it. Okay, so I want to find the critical value. Remember, CV is what I use for critical value. And the way that we get it is we use inverse norm. Now, when I use inverse norm, remember I have to use the area that's to the left. I have the area in the right, okay? So 0.05 is the area in the right tail. Keep in mind the total area under the curve is 1. So this region would be 1 minus 0.05. The area in the left tail, the area to the left of Z, will be 0.95. 1 minus 0.05. So when I get ready to find that critical value, I have to use the area to the left, which is the 0.95. Okay, and then because it's Z, remember the mean is 0, the deviation is 1. Okay, all right, so let's find the critical value. Inverse norm. The area to the left is 0.95. I have a mean of 0, deviation of 1. Remember, I don't change what kind of tail it is. I keep it left and I hit paste. So my z-score, my critical value is 1.64. Okay. So this right here, this z value, this bind or this bound here that separates the unshaded region from the shaded region is 1.64. Now, so right here, they're asking us to either select A or B for critical value. We only have one, so we're going to select A. And we're going to put on this blank here. You can't see it, but on the blank, when you're actually on the computer, you write in or type in 1.64. There's only one, so we choose A. When there's two, you choose B. Okay? So our rejection region would be the area to the right of 1.64, the area greater than 1.64. So the rejection region would be Z is greater than 1.64. It would be B. And we say greater than because that is the area shaded to the right of 1.64. Okay, so make sure you understand that. Now we're going to find the test statistic and compare the test statistic to the critical value. In other words, determine if the test statistic lies here to the right in the shaded region or here to the left of it in the unshaded region. That shaded region represents your rejection region. Okay, that's why we just selected that there. This is the rejection region. Okay. All right, so our test statistic is Z equals X bar. Over here. Z equals X bar minus mu over sigma divided by square root of N. So X bar, which was 900, minus the mean, which is 860, over the standard deviation, which is 126, and then dividing that by the square root of N, which is 62. So I'm going to go ahead and see what 900 minus 860 is, which is just 40. And then I'm going to hit divide that by parentheses 126 over the square root of 62. So I put that whole thing in parentheses so the calculator knows that I'm dividing 40 by this whole value. Excuse me. So we got 2.4996. Let's just go ahead and say 2.5. Round that to 2 decimals, 2.50. Okay. That's our test statistic. So take a look at the picture. That's why a picture is worth 1,000 words. Your bound here is at 1.64. 2.5 is bigger than 1.64, so it lies to the right, which would place it in the rejection region. So 2.50 is bigger than 1.64, so it lies to the right of 1.64 in the rejection region. Okay, so we are going to reject it because it is in the rejection region. So cross out C and D because it says fail to reject. So we know it's either A or B. And it is B because it says reject H naught because the standardized test statistic is in the rejection region. So B is the correct one. Okay, it is in the rejection region. And now we're gonna interpret our decision. At the 5% significance level, there blank enough evidence to blank the claim. Okay, let's go back here. So we reject H naught. Let's be clear on this. We reject H naught, but the claim is HA. So think about it. You're rejecting H naught. You are throwing away H naught. Okay? You are left, therefore, with HA. And lo and behold, the claim is HA. So all you're left with is HA, which is the claim, which tells you or should tell you that your evidence supported your claim. You were able to throw out HO and therefore support HA. When you're able to get rid of one, it means the other one, from your data must be true. So we're able to support HA. So at the 5% significance level, there is enough evidence to support the claim that the mean monthly residential electricity consumption in a certain region is more than And these would be fill in the blanks. These would be pop down that you actually choose from. Except for right here, you actually will type 860 because that's the claim value. So at the 5% significance level, there is enough evidence to support the claim that the mean monthly residential electricity consumption in a certain region is more than 860. Okay? And again, these are be little drop downs where you actually select is or is not here. Here you would say, you would select between support or reject, and then is more than, is less than, all that, and then you'll type the number. Okay? And you can see the choices right here. All right. Okay, let's see. I'll do number 4, and then I'll do a p-value one. And then I think we'll go on to the t-distribution. And I really don't have to do this one because it's very similar to the previous ones. The main thing I want to make sure you're clear on is choosing the picture that identifies the rejection region. So I'm going to walk through this one, especially for that part. Okay, so it says a light bulb manufacturer guarantees, that's another word for claims, a light bulb manufacturer guarantees that the mean life of a certain type of bulb is at least 72 or 772. Okay, so the mean mu, let's just write down claim here, the mean mu is at least. So you got to make sure you understand how to translate, okay, how to translate English to mathematical statements. So you got to have an understanding of what is at least means so that you'll use the correct mathematical symbol. So is at least, think about it. At least means this is the smallest or this is the lowest and anything else bigger than that. Okay, so that's what we're talking about. So at least means greater than or equal to 772. That is our claim. So is at least means 772 is the floor, and we're talking about all values 772 and above. Okay, so that's our claim. Now, because we've got the claim now and we can see that it contains equality, we can denote whether it's HO or HA. Your claim contains equality, so it has to be HO. Mean mu is greater than or equal to 772. Okay? Because your claim contains greater than, your HA, your alternative, must contain less than. And remember, HA does not have equality, so it's strictly just less than. Okay? And I went ahead and wrote claim by HO. That way we don't forget the claim is H naught, is HO. All right? Now, we do also have a left-tailed test, because the alternative hypothesis uses the less than symbol, so this is a left-tailed test. So let's go ahead and identify the null and the alternative hypotheses, also with the right one labeled as claim. It looks like it would be A, greater than or equal to 772, that's the claim, less than 772. All right. Okay. Now I'm going to go ahead and draw a picture, even though I'm going to choose a picture here. I'm going to go ahead and draw me a sketch. So this is the left-tailed test. So notice I'm shading here to the left. I'm going to find this critical value. I'm going to find that critical value that corresponds to this shaded region here. Okay. Now, alpha, our test level, is 0.08. Alpha is the value that corresponds to your critical value. So if you have a left tail test, alpha is that area in the left tail. If you have a right tail test, alpha is the area in that right tail because it refers to the critical value. Okay, if it was two tail, you would split alpha. But in this case, alpha is here in our left tail, and that represents our rejection region. Okay, so we're going to find that critical value that corresponds to it by using inverse norm. The area to the left of our z-score that we're looking for is 0.08. And remember, it's a z-score, so the mean is 0, the deviation is 1. So area mean deviation. So inverse norm, we've got 0.08 and then 0.1. Hit paste. So we got a negative 1.41 if we round that to 2 places. Now, if this had been a two-tail test, you see how it says use a comma to separate answers as needed. If this had been two-tail, you would have written negative 1.41, comma, positive 1.41, or just 1.41. Okay, that's what they mean there. But we only have one, so we don't have that to worry about. We just type negative 1.41. Okay, and I rounded that to 2 decimals, which meant that 0 gate went up to be a 1 because the 5 follows it. Okay. All right, now on the computer, you can see these regions a little bit better. They're actually shaded a little, so you can actually see what's shaded and what is not. So I'm going to show you what the picture would look like. It didn't copy well. Okay. So each of these pictures has a fail to reject region, which is the unshaded region, and a reject region, which is the shaded region. Keep in mind, you have a left tail test, so your shaded region, your rejection region should be the left tail, okay, which would be A. And that means that z-score that corresponds to that is negative 1.41, okay? Now what we want to do, so we're going to select A. A is definitely the right picture. Now what we want to do is figure out where our test statistic lies in reference to our critical value. Does it lie to the left, which would place it in the rejection region, or does it lie to the right, which would place it in the fail to reject region? So if we get a z-score that is bigger than negative 1.41, it would be here to the right. If it's smaller, it'll be here to the left. So let's get it. So we got x bar minus mu over sigma divided by square root of n. X bar. Let's see. I didn't finish reading the problem. So let's go back up here and finish reading so I can recognize what x bar is and all that other stuff. It says a random sample of 26 light bulbs. Okay, so n is 26. Has a mean life of 761. So that sample has a mean x bar of 761. It says assume the population is normally distributed and the population standard deviation is 60. So sigma is 60. Okay. And then we're told at alpha equals 0.08, do you have enough evidence to reject the manufacturer's claim? Notice that they use the word reject. And the reason they use the word reject is because H naught is the claim. Okay. All right, so we got our details now here, our stats that we need, and we're going to plug them into this formula. So x bar is 761. From that, we're going to subtract 772, which is our mean claim value, our mean mu value, over sigma, which is 60, divided by the square root of n, which is 26. So this would be negative. So let's just see, 761 minus 772. We get a negative 11. Then we're going to hit divide that by parentheses 60 over the square root of 26. Excuse me. So we get negative 0.93. Okay. So let's put right here, negative 0.93. We're around to 2 decimals. So I want you to think about this now. Negative 0.93. I would rather be in debt just 93 cents than be in debt $1.41. So negative 0.93 is bigger. It's in this region. It's in the fail to reject region. So let me say bigger than negative 1.41. So it's in the fail to reject region. Okay. So we will fail to reject. That's our decision. And then we're going to choose the right interpretation. So we definitely failed to reject. So the two that say reject, throw them out. Throw out A, throw out D. So it's either B or C. Let's read both. B says failed to reject H naught. There is not sufficient evidence to reject the claim. No, there isn't sufficient evidence to reject the claim because we're failing to reject. Let's read C just to make sure though. Failed to reject H naught. There is sufficient evidence to reject the claim. No, that's contradictory. It says failed to reject, but then it says there is sufficient evidence to reject. No, we didn't reject. We said failed to reject. So therefore, there is not sufficient evidence to reject. So the answer is B. Okay? So after you make the decision, then here, that multiple choice there is the interpretation. Okay? Right. Now this one is actually going to take a turn and have us to use the p-value method. Okay? I'm going to show you on an illustration, and I'm going to put it in the calculator. Okay, so it says use technology to help you test the claim about the population mean mu at the given level of significance alpha using the given sample statistics. All right, so here's our claim. I'm going to circle it, and then I'm going to go ahead and write what HO and HA are. So our claim is that the mean mu is greater than 1230. So notice that this is a strict inequality. So the claim has to be HA. Mean mu is greater than 1230. So I'm going to go ahead and put claim here by HA. All right. Now, to get HO, we have to do the opposite of the opposite of greater than. We're going to have less than, and then HO has to have equality. Okay. Excuse me. All right. So now just choosing these correct statements here. Notice that some of these use the wrong number. They use the statistic value, and that's not the value that should be there. It should be the claim value, the 1230. So it appears that the answer is going to be E. Yeah. Okay. All right. Then it wants us to calculate the standardized test statistic. I am going to put the formula here. I'm going to show you how we do it by hand as well. All right, so I'll go ahead and do it by hand. X bar is the 1248.99. Mean mu is the 1230. And then sigma, we've got 204.87 over square root of n, which is square root of 200. All right, so 1248.99 minus 1230, and then divide that by parentheses 204.87 over the square root of 200. So we got 1.31 as our test statistic. Okay. Now, notice they don't ask you about the critical value at all. Now they want the p-value. Well, you remember the test level alpha corresponded to the critical value? Remember the alpha was the area, okay? It was the area under the curve in the shaded region, and then your critical value corresponded to, I'm sorry, right here, corresponded to alpha. Well, in this case, the p-value is the area that corresponds to your test statistic, okay? So what I'm going to do is just like before, I'm going to determine what kind of test this is. It's a right-tailed. Right-tailed test. So I'm shading here to the right. My test statistic is the 1.31. It's the bind. And I want the p-value that corresponds to it. P-value is just short for probability value. So it is the area under the curve that corresponds to that z-score, that corresponds to my test statistic. So My test statistic is 1.31. The area that's shaded is the area in the right, or the area to the right of 1.31, because it's the right tail test. That area is the p-value that I'm going to find. Okay? So you can actually use the calculator, and you don't even have to worry about using anything else after this. When it's p-value, you can just use the calculator because it says use technology. I just wanted you to have an illustration of what the p-value actually represented. It is the area under the curve that corresponds to the z-score test statistic. So p-value is the area under the curve that corresponds to the test statistic. Okay? So I'm going to use the calculator now. So I want to perform a test. I want to perform a p-test. If I can spell. I want to perform a p-test. How do I pull that up? I press the stat key. I go over to tests. And I select z-test. That first one. Okay? I select z-test. And the reason I select the z is because you're actually dealing with a problem that gives you the population standard deviation. When sigma, the population standard deviation, is known, when sigma is known, it's a z-test, okay? When sigma is not known and instead you're given S, then you use a t-test. So we will either use number 1 or number 2. In this case, we're using number 1, a z-test. So I'm going to select that, and then I'm going to put everything into my calculator, okay? Now, this is stats, okay? I don't have a list of data values that I'm putting in the calculator, so I'm actually using stats. So I'm going to keep that on stat. If it was on data, it would have list, okay? And we don't have a list, we don't have a data set. So I need to make sure it's on stats. Okay. So my mu is my claim value, that's 1230. My sigma value is 204.8787. My X bar value, my sample mean, is 1248.99. My N is 200. And what kind of test is this? This is a right tail test, so I make sure I use right here the correct symbol, the greater than symbol, the symbol that's matching from the alternative hypothesis. Okay, and I go down to calculate. And there it gave me my z-score, which I already had found anyway, and my p-value that corresponds to it. We're going to round to 3 decimals, 0.095. Okay, 0.09, that 4 goes up to a 5. All right, now determine the outcome. Well, to make a decision, you're going to compare the p-value to alpha. If p-value is less than or equal to alpha, then you will reject H naught. If p-value is greater than alpha, then you will fail to reject. Okay? So our p-value is 0.095. Our alpha is 0.07. So p-value is bigger. P-value is greater. 0.09 is greater than 0.07. So we will fail to reject. So right here in this first blank, we're going to select fail to reject. And it says at the 7% significance level, there blank enough evidence to blank the claim. Okay. Well, our claim was HA. Okay. So because we failed to reject, we say there is not. Anytime you fail to reject, that means there is not. Either there is not enough evidence to reject or there is not enough evidence to support. But because it's failed to reject, you make sure you use the words is not. When you use the word reject, you use the word is. Okay? So it is not. Okay? And then because HA was the claim, we say there is not enough evidence to support. Okay? Make sure you understand that. Okay? This is one of the harder ones to translate, only because you got to really understand that while the claim is HA, your decision is based on HO, okay? So we failed to reject HO, okay? The claim was HA. So if we failed to reject HO, that means we still have HO and we also still have HA, and we don't know which one is correct, okay, when you still have both. Because failing to reject means you did not throw it away, okay? You're not saying it's accurate. You're not saying it's true. You just don't have enough evidence to say that it's false, so you can't throw it out. And what that means is either of these now could be true, okay? So we simply just have to say there is not enough evidence to support, okay? All right, I'm going to show you one more of these, and then I'm going to show you the t-test. I think I got a problem using the t-test. Yeah. Okay, a random sample of 86 eighth grade students' scores on a national mathematics assessment test has a mean score of 266. So we're talking about the sample right here. A sample of 86, and that sample has a mean score of 266. So X bar is 266. It says this test result prompts a state school administrator to declare. So here comes the claim. They're declaring that the mean score for the state's eighth graders on this exam is more than 260. So the claim is based upon this sample. Their claim is that the mean score for all eighth graders is more than 260. There's our claim. Okay, it says assume the population standard deviation is 30. So assume sigma is 30. And it says at alpha equals 0.11, so at an 11% confidence level, is there enough evidence to support the administrator's claim? Notice that they use the word support. They use the word support because HA will be the claim. HA is the claim because our claim does not contain equality. So mean mu is greater than 260 is HA. Okay. Now, HO would be the opposite of greater than, which would be less than, and then we got to contain equality. So less than or equal to. And remember, the claim is HA, so I'm going to go ahead and put claim right there. So we just need to choose the correct one that matches less than or equal to 260, greater than 260, and HA is the claim. That would be F. Okay. Now at this point, we can use the calculator. We're going to perform a z-test, which using the calculator is the p-value method. Okay. So I'm going to select, clear that off. I'm at my home screen. I'm going to select stat. I'm going to go over to tests, and I'm using number 1, a z-test. And it's a z-test because I'm given the population standard deviation. I'm given sigma. So use a z-test when you're given sigma. So I'm going to select that, and I'm going to put in my stats. My claim value is 260. My standard deviation is 30. My sample mean is 266. My sample size is 86. And then this is a right tail test because the alternative hypothesis has the greater than symbol. So I need to make sure I select the greater than symbol here. It's telling me what kind of test it is, or I'm telling the calculator what kind of test it is. And then I go down here to calculate, or I can even hit draw. Let me show you that. Hit draw. Actually, my window is not great. So let's go zoom. Actually, it wasn't through. Okay. I may have some other stuff on here is what I'm concerned about. So let's just go back and let's just go down here to calculate. I don't have to see the picture. But I was kind of going to show you the picture because I want you to know that it's still a bell-shaped curve. It's a right tail test because the greater than symbol is used. So I can draw my own picture though. I should have cleared my calculator out, and I think I still can. I'm going to show you. But let me just draw it by sketch here, or by hand. Right tail test. This shaded region is my p-value, and it will correspond to my test statistic, which is 1.85. Remember that the p-value corresponds to the test statistic. Okay, so our test statistic is 1.85. We also have our p-value. It is 0.032, 0.032. And we're going to compare p-value to alpha. So p-value and alpha. Our p-value is 0.032. Alpha is 0.11. That's our test level. P-value is smaller, so we have the less than symbol there. And because p-value is smaller, we reject H0. When p-value is less than alpha, reject H0. Okay. All right, so we reject H0. That means we're throwing out H0, which means we only have HA left. HA happens to be the claim. If you only have HA left and HA is the claim, that means your evidence supported the claim. So at the 11% significance level, there is, when you reject, you say is, there is enough evidence to support the administrator's claim that the mean score for the state's 8th graders on the exam is more than 260. So we say there is enough evidence to support the state administrator's claim. Okay, key, kind of just a little hint. Notice that they use the word support up here. So you should know to use it down here. Okay, there is enough evidence to support because it says it. Excuse me, because it says it up there. Okay, excuse me. All right, a couple more things here that I want to just mention as far as the t-test. So when you have a standard deviation given, but it's a sample standard deviation, not the population, then you have what's called the t-test. It acts very similar to a z-score or a z-test. The only difference is you don't know anything, you don't know much about the population. You don't have the spread of the population. You only have the spread of the sample. So it's not going to be as telling when you don't have more information about the population. So we're not able to use a z-test. Instead, we use a t-test. So this first example here is just asking us to find the critical values and the rejection regions for a t-test. And this is where your table you have the t-table, the t-distribution table that will pop up, or you'll have a little icon there that allows you to click on it. And this is what it looks like. It's only one side table. And it has a row here for one tail or when you have two tails, okay? And the alpha, the level of confidence or the level of significance is given. So you will first denote whether it's a one-tailed test or a two-tailed test, and then you'll locate your given alpha. And then you'll find the degrees of freedom that correspond to that alpha, okay? Degrees of freedom is simply the sample size minus 1. Why they subtract 1? Some mathematician came up with that years and years ago, just stating that it took away the little minute error that would be in place if we just use n. So instead we use n minus 1. Okay, it's kind of arbitrary, but anyway, we use n minus 1 for degrees of freedom. Okay. Also, if you have a left-tailed or a right-tailed test, you will use that one tail with the alpha. And if it happens to be left-tailed, you'll take the value and make it negative. If it's right-tailed, you'll take the value and keep it positive, okay? So that just all depends upon whether in your problem you have a left-tailed or a right-tailed. So let's look and see what we have here. It says find the critical value or values and the rejection regions for the indicated t-test, level of significance alpha, and sample size n. All right, so we have a two-tailed test. So I'm going to draw a little sketch here, just so that you have an understanding. Because it's two-tailed, that means you got two critical values. One is negative t, and one is positive t. And you could put like a t sub 0 on there, okay? Okay, after you draw your picture, your sketch, understand that the critical values that you're going to be finding basically set up your rejection regions, okay, if we were going a step further with this. Okay, so your critical value will be found from the table. We're going to go to the table. We're going to locate our alpha in our two-tailed column. So right here, two-tail, alpha is 0.01, so that's all the way here. And degrees of freedom is n minus 1. Well, n is 14, so our degrees of freedom is 13. So here is two-tail. Here's the row we're going to be on, two-tail, and our alpha is this alpha all the way here to the right, 0.01. And then we go down until we see our degrees of freedom, which is 13. So the value that's from our table is 3.012. So we have a negative 3.012 and a positive 3.012. So right here we use a comma to separate them. Negative 3.012, comma 3.012. Okay? And that just means this value is negative and this value is the positive. Okay? Now it wants us to determine the rejection regions. Well, you have two rejection regions. You have this region here that's to the left of negative t. Okay? So to the left or less than, so this is where t is less than negative 3.012, because that value is negative 3.012 and it's the area to the left, so we say less than. Or t is greater than positive 3.012, because that is the area to the right. Okay, when it's to the left, we say less than. When it's to the right, we say greater than. So the area to the left of this negative 3.012, and then the area to the right of this positive 3.012. Okay, and I should have probably said and, not or. So we have less than and greater than. So we're going to select C here, right here. It looks weird because there's a blank and then it gives you another blank. The blank didn't copy. So this should be negative 3.012 and positive 3.012. Okay. So those are your rejection regions. Okay. let's perform a full test here, a full t-test. And yeah, that'll be it. So it says use the t-test to test the claim about the population mean mu at the given level of significance alpha using the given sample statistics. Assume the population is normally distributed. All right, so our claim is that the mean mu equals 52.7. Okay, and because it contains equality, the claim has to be H naught, HO. So mu is not equal to 52.7. So the way we set these up, even though it's a t-test, because it does say use a t-test, the way that we set this up is very much just like we did before, okay? As far as setting up the hypotheses, that hasn't changed. Your claim is HA. I'm sorry, your claim is HO because it contained equality, okay? All right. Now that we've got our hypotheses written, let's just choose the correct one. It has to be C. Okay. Now let's get our standardized test statistic. Well, you technically, yeah, let's do it. You can technically get it from the calculator as well, but they want us to find the critical values. We're going to use the table for that anyway. So let's just go ahead and just do it by hand. All right. So to get the standardized test statistic, that's T equals X bar minus mean mu over S divided by the square root of N. So very similar to getting the test statistic Z. The difference is we don't have sigma, we have S. We have the sample standard deviation. So instead of being given sigma, we're given S, and that just changes the formula just a little bit right there where sigma used to be, we have S. So we still have the sample mean, 51,208, minus the mean mu, 52.7, over S, which is 1,600, divided by square root of N, which is 18. Okay, so I'm going to put in 51,208 minus 52.7, and I get 1492, negative 1492. I'm going to divide that by parentheses 1,600 over the square root of 18. So I get a negative 3.96 when you round that to 2 decimals. Negative 3.96. Okay, and basically I'm going to compare those to my critical value or critical values because I should have 2 critical values, and I should have 2 because this is a two-tailed test. How did I know it was two-tailed? Because of the symbol used on HA, remember? So because this is two-tailed, I'm going to have 2 critical values, okay? So negative T sub 0 and positive T sub 0. And what I'm going to do is figure out how the test statistic T compares to the critical values T sub 0, where they lie. So let me get the critical values. Remember, I'm going to use the table, and I'm just going to pull or put in, I should say, my information that I need in order to use the table. Is two-tailed. My sample size is 18, so degrees of freedom is 17. N minus 1. All right, my alpha, my test level is 0.05. So when I go to my table, I've got two-tailed. Okay, my alpha is 0.05. So I'm on this same row here, two-tailed alpha 0.05. My degrees of freedom is 17. Okay, so I'm going to scroll down here and then over here, right there. So I've got 2.110, so I have a negative 2.110 and a positive 2.110. So negative 2.110, comma, positive 2.110. Okay? So right here, this is negative 2.110. This is positive 2.110. Now, where does the critical value, or where does the test statistic lie in reference to the critical values? Let's see. Negative 3.96, that is smaller than negative 2.11. So it lies here somewhere. It lies in the rejection region. Technically, it lies in this particular region, but both of those are rejection regions. So if it lies in either of those, then you will reject H naught. So reject H naught. H naught is the claim. So you are rejecting the claim. Okay. So we reject H naught. That means you can cross out C and D. So we reject H naught. That means there is enough evidence to reject the claim. There is enough evidence to reject the claim. So that would be B. Okay. Very similar to what we did with the Z-test critical values. It's just a different table. Okay, we had to use the T table for this T-test. Okay. All right. Well, that is all I have for today.